Okay, so today we're going to start a new chapter. Chapter 4 is going to be all about transformations, so changing shapes, positions, orientations, changing their size. And so we're just going to kind of go through the chapter, kind of talking about one transformation at a time, then how we can combine transformations and things of that nature. So this first section is going to be quite a bit of information. It's going to be like the vocabulary for the entire chapter, and then we're going to talk about the first type of transformation, which is called translations, as you see here. Okay, so some background information that we need before we can start talking about our different transformations. For translations, we're going to be needing to know a little bit about vectors. So vector is a quantity that has both direction and magnitude. So it kind of tells you which direction we're heading and how far we're heading. In the coordinate plane, it's going to be represented with an arrow. So down here in the picture, you can see that vector JK. The arrow dictates the direction that we're heading. So we're starting at point J, and we're traveling to point K. So that's what a vector is going to look like. Now, the two things you need to know about vectors is how to name them. So we name them just like we did with rays. So we're going to have the starting point P, where we're going to travel to Q, and then we have our little arrow symbol above to show which direction we're heading. So we got P traveling to Q, just like we have in the picture here. So that's the one thing, is knowing how to name the vector. Second, we need to know what's called the component form. This is an important part here because this is what we're going to be using as far as translations are concerned. So when we want to know how we moved from one position to another, instead of looking at the direct distance from P to Q, we're going to look at it in component form. We're going to say, okay, well, how far right and left did we travel? And then how far up or down did we travel for this particular problem? So with component form, that's what we're talking about here. We use these little arrow brackets. Okay, they're not parentheses. You need to make sure they have an actual point at the end there. And then there's going to be two numbers in here, just like an ordered pair. The first number is going to tell you whether you went right or left. And the second number is going to tell you whether you went up or down. So it's always about how far did we go right or left first, and then how far up and down did we go. So the right is going to be a positive number. So anytime you see a positive, it means head to the right. If you see a negative, that means you're going to head to the left. Okay. For the up and down, if you're going to go up, you're going to see a positive number. And if you're going down, you're going to see a negative number. So knowing what the sign tells you is also important. So how far do I move and in which direction? So the example here for PQ, we see in the picture that we had to go 5 units to the right and 3 units up. So 5 units right would be a positive 5. 3 units up would be a positive 3. If I had put a different vector in here, let's say S traveling to T here, well, for S to T, we'd have to go left 3 units. So we go 1, 2, 3 to the left. So that means I'd have a negative 3 for the first number. And then I would go down 2, so negative 2 further down. So the positive, negative tells us which direction, and then you have the right, left for the first number, up, down for the second. Some more information here before we get into the different types of transformations. A transformation is a change in position, shape, or size. Now, for our purposes, we're not really going to do much with changing the shape of the object. We're going to mostly focus on position and size. Two terms that you absolutely have to know for this chapter. You got the original figure is what we're going to call the pre-image. So if I start with a triangle, call it ABC for instance, if this is going to be my original figure, I'm going to call this my pre-image. And then if I take that triangle and let's say I slide it over here. Okay, so I slide it over here. I'm going to use some notation we're going to talk about here in a second. So A prime, B prime, and C prime. So I go from there to there. Then this is going to be my image. So where did I end up is going to be the image. You need to know those two terms because we're going to use those a lot in the homework on the examples and in the instructions. Quiz, test is going to talk about pre-image, image. You need to know what's going on there. So pre-image is the original, image is the new. As far as transformations, we have 3 that we're going to talk about for the first part of the chapter. So we have like a reflection here where we flip across a line. So we took this domino and we flipped it across this line so it turned over. We could slide the domino, so we just slide it over to here. So now it's just the same domino in the exact same orientation just slid over to the side. Or we can churn it, so we can rotate the domino as well. So this would be a rotation. So those are the types that we're going to focus on to start with. Another key term that you have to know, so this is almost as important as the pre-image and image, a rigid motion. So anytime you see that term rigid motion, and you're going to see that a lot, they're just telling you that when you perform the transformation, the size doesn't change. So if we notice in the pictures below, when I went from my pre-image here to my image in the triangles, I didn't change the size of the triangle. All I did was change the way it looked and where it was located. So the size stayed the same. Same thing over here. When I reflected my hexagons here, they stayed the exact same size. So rigid motion, you want to think to yourself, same size. Okay? A mapping. A mapping is what we use to tell how we went from one location to another. So how did we get from this figure to this figure? So from the pre-image to the image, what happened? So down below in the picture here, we have this triangle in black, ABC, and then we transform it by shifting it and reflecting it over to this triangle on the right here, A prime, B prime, C prime. So we had this transformation. Now the mapping would be this statement right here. It's telling us which direction we're heading. So I went from triangle ABC to triangle A prime, B prime, C prime. So it just tells us which direction we're heading. So you're going to tell what the figure is and how we went from there to the other. And so we're going to write rules that tell us how that mapping works. How do we get from that figure to that figure? The other thing to note here is prime notation. This is going to be something that's extremely important throughout the entire chapter. The image in a figure will typically have what we call prime notation, which is just a fancy way of saying add an apostrophe. So A in the pre-image is just regular A. When I reflect, in this case, over to A prime, we use that little apostrophe to note this was the image point. I came from A and went to A prime. I went from B to B prime and so on. So that prime notation is going to be something we use a lot. So that's going to be how you tell whether you have an image or pre-image. As far as translations, a translation is just sliding. We're just sliding an object from one point to another. So like for here, I got triangle ABC getting slid down to triangle A prime, B prime, C prime. So I didn't change the way it faced. I didn't change the orientation of any kind. All I did was just slide it from one location to another. Translations don't change the size of an object. So those are rigid motions. Like we said, this is going to be a term we see a lot. So it's a rigid motion, which means we don't change the size. Now, as far as translations, one of the things you're going to have to be able to do is looking at a translation like we see here, how did I get from triangle ABC to triangle A prime, B prime, C prime? So what did I do to get from one to the other? So with translations, the whole figure moves in the exact same direction. So exact same distance, exact same direction. So all I've got to do is pick out one point, so like point A. And I got to figure out, well, how did I get from A down to A prime? So this vector took me straight from A down to A prime, and I want to know, well, how did I get there? So with vectors, we said we use component form. How far right and left, how far up and down. So starting at point A, I figure out how far to the right I had to go because I need to go right to A prime. So I go 1, 2, 3, 4, 5, 6. So I went right 6 units. And then to get to A prime from here, I'm going to have to go down. So 1, 2, 3, 4, 5. So you got to know, what direction am I heading? Right 6, down 5. Well, so for component form, remember we have those arrow brackets. And then we said the first number is right or left. Since we went right, that's a positive 6. And then we went down, so the second number is up or down. Down would be negative, so that's why we get the negative 5. So this component form tells me I went right 6. And the negative 5 tells me I went down 5. Okay, so those numbers are going to be extremely important for you to know what they mean. The other thing you're going to have to be able to do is use what we call translation rules. So same exact figure, so exact same idea that we just had here. Triangle ABC is going down here to triangle A prime, B prime, C prime. I want to know how I went from A to A prime. And so again, I look at kind of the right, left, up, down. So in this case, though, we're talking about, well, how does X and Y change? So how do our X and Y values change? So if we think about the points here, A was at negative 5, positive 5, and A prime is at 1, 0. So if I think about what happened to X and what happened to Y, notice when I went X, I went from -5 all the way up to +1. Well, the only way to have done that is if I added 6 to my x value. So that's where this x plus 6 comes in. If I look at my y values, for my y values, I went from 5 all the way down to 0. Well, the only way I could have done that is by subtracting 5. So that's where the y minus 5 comes in. You can also do this without the points, just again, thinking about, did I move right or left or up or down? This first part of the term is going to tell us right or left. So I went right 6, which is why we had the plus 6. And then we went down 5, which is why we had the minus 5. So it's the same thing as component form. The only thing we're adding is the x and y for the actual points. So I'm going to take x and add 6, that means right. Y minus 5 means down. And then vice versa. If I said x minus 2, that means left 2. If I said y plus 5, that means up 5. So this is a translation rule, and that's going to be something we're going to write for the transformations. Another type of problem you need to know how to do is working with actually applying the transformation. So on the transformation below here, it says take xy, add 5 to x, add 1 to y. So if we think about what that means, x plus 5 means go right 5. And y plus 1 means go up 1. So what they're telling us is take every point here, point A, point B, and point C, and move it to the right 5 and up 1. So for A, we're going to go 1, 2, 3, 4, 5, up 1, and then we label it. Now it's an image, so we go A prime. And then I take C and I move it to the right 5 and up 1. And I'm going to call that C prime. And then I'm going to take B and I'm going to move it to the right 5 and up 1. And that's going to be B prime. So I just take all 3 points, I move them to a new location, and then I'm going to use dotted lines to denote this new figure here. So there's my new image there, and if you want to, you can even kind of shade it in to make it stand out. So there's my new triangle. Now the other thing that we have to do is give the coordinates of the image. So they're going to say, well, once we move, where do we end up? So A prime, if we look at the picture, or if we use the points, we add 5 to x, so we ended up at +2. Add 1 to y, we end up at 2. So I can do that from these points using the +5, +1, or I can just look at the graph. A prime was at +2, +2. B prime, looking at the graph or using my rule, is located at 4, -1. And then C prime is located at 4, +1. So not only do you have to have the graph with the picture, you also need to have the actual points. Where are these new points located? Okay. As we're looking at this too, make sure when you graph, always make sure you label your points. Like if you don't label points, you're going to lose credit on some of the problems that we're going to be doing here. So you have to label the points so I know what's the original, what's the new, what's the pre-image, what's the image. Okay, so that's one type of problem. With component form, it's no different. The numbers tell you right or left, up or down. So if when I have a 0 here, this is something I want to talk about real quick. 0 here means that there is no right or left. So I'm not going to move my object whatsoever either direction. Okay? So when I have a 0, I'm not moving it any direction in that particular right or left or up or down. So if I'm looking at this problem, they tell me A is at -4, 3, so I'm going to put A here. B is at -1, -1, so I'm going to put B here, and then C is at -5, +1. So there's C. So here's my original figure. Now what this 0, 3 tells me, 0 says no right or left. -3 tells me that I'm going to go down 3. So I'm just going to take each of these points and move it down 3 units. There's C prime, A goes down 3, there's A prime, B goes down 3, there's B prime, and then I would connect. So there's my new figure, and then I would just record the points. So where's A prime, where's B prime, and where's C prime, which you guys can do. As far as writing translation rules, so in this case, we're writing the rule. How did we get from one to the other? So the first thing we have to know is which direction are we supposed to be heading. So if I look at my note or my points, notice how one is regular, A, B, C, D. The other has that prime notation, A prime, B prime, C prime. That means this is my pre-image. The prime would be my image. So that means I'm going to be going from here to here. So that's important to note so I know which direction I'm heading. So I start with my translation rule. All translation rules start the same. It's going to say x, y, and then an arrow. So I'm going to take x and y and map it to here. And so in this case, I just pick a point and figure out how it traveled. So for B, I go right 2. And then from there I go up 4. So if I go right 2, that means I took x plus 2, positive for right. And then for up, I'm going to have plus 4 for y. So there's my translation rule. In component form, I don't need the x's and y's. All I need are the numbers. So we said we had positive 2 and positive 4. And then don't forget those arrow brackets with the points. Okay, so that's what we're looking at there. For this next one, again, knowing which direction we're heading. So I've got my pre-image on top, A, B, C, D, going to my prime notation, A prime, B prime, C prime. Now, as far as the rule, again, I have my x, y. And so from there, what I'm going to end up doing is I want to figure out, okay, well, how did A get to A prime or B get to B prime, whichever point you want to use. So A did not move right or left. Now, if I'm not going to move right or left, that means I have a 0 involved. So I could write something like x plus 0 for the x. As far as y, I'm going down 5 units, so I'm going to have y minus 5. Now, when you don't move right or left, or you don't move up or down, you could write the x plus 0 for the translation rule, or you could have just simply written x, because x isn't going to change. So that same statement could look like this as well, so just be aware of that. As far as component form, we just get rid of x and y. So I just want the 0 and the negative 5 and my arrow brackets. Okay. Last thing, if we're going to do multiple transformations, so we're going to go from one to another to another. So r is at negative 3, 5. S is at negative 1, 2. And so I have this line segment. I want to translate it twice. So the first one says go right 3 and down 5. That's what the plus 3 and minus 5 means. So I'm going to take r, I'm going to move it right 3 and down 5. So this is going to be r prime. And then I'm going to do s the same way. So I'm going to move it right 3 and down 5. Whoops. So down here, that's going to be s prime. And then I connect. Now when I go to move a second time, I see that they want me to move it left 5 and up 1. So that's the minus 5 and 1. So I'm going to go left 5 and up 1. Now this is a second move. So what's going to happen now is instead of just r prime, I'm going to go ahead and put 2 primes. So we call that r double prime. And then I'm going to move s prime left 5 and up 1. And that's s double prime. So then when I'm looking here, that's my final location. So when you have multiple transformations, make sure you use multiple primes to denote the difference between the first move, second move, and whatever else. With that, you should be able to work on the worksheet for the day. If you have questions, make sure you ask in class, email, whatever you got to do there to figure that out. Check the answer key on Google Classroom when it comes out, but you should be good to go with that.